side of the funnel that does not have a filter paper folded over it on the flat surface. Use a capillary tube to draw up some of the Kool-Aid concentrate. So black cherry, touch the end of the capillary tube to the dot you made previously on the side cone that has one layer. So here's my dot. There's that. The Kool-Aid should release from the capillary tube onto the paper. If it does not, try to apply the Kool-Aid capillary tube. You want a spot that is about 5 millimeters in diameter. A large spot will not result in a good separation. That is kind of large. Let's try it again. Let's just try to put a tiny little dot. Okay, that's a little better. Allow the spot to dry for 3 to 5 minutes. So we're going to do that to each of the different kinds of Kool-Aid. So that's 1. Two. And 3. Place 1 centimeter, 25 to 30 mils of eluent in the bottom of a 400 ml beaker. So here's my sodium chloride, 0.1 moles. There's 1 centimeter. Be a little more. Make sure the cone is opened up so it is round at the top. Place the cone at the top of the beaker and push the cone down in the center until the tip of the cone just touches the bottom of the beaker. Make sure the level of sodium chloride solution is below the spot of the Kool-Aid. So I'm going to get 3 different beakers so we can do them all at the same time. So note, this beaker isn't dirty, it's just really scratched. Okay, now that these have dried up, we're going to place the cone in the beaker. So the round side is up, just like this. We're going to push the cone. Let's see here, right here. No, where is that? Like this. Just like that. And we're going to do that for each of them. Allow the solution to be pulled up in the paper through the capillary action until it is within 1 centimeter of the top of the paper, so 10 to 20 minutes. Do not let the solvent go up to the top past the paper. So we're just going to let that sit. Okay, now that the solution has gone up, we're going to mark where the solvent front stopped. So I'm just going to remove these from the beakers. So as you can see, this is the front, the back. So do not let solvent go up on the top, past the top of the paper. Mark where the solvent front stopped. Here, here, and here. Mark the top of the solid front where the end of the solvent traveled. Measure the distance from the dot you made in the pencil to the center of each colored dot in millimeters. Okay. use my ruler. It's kind of overkill. But, so for the red, we didn't see it travel too far. It does have a little bit of traveling, but it's going to be four millimeters. For the, so that was for grape. So for orange, it's going to be 11 point, what did I see here? .2 millimeters for orange. And then for black cherry, it's gonna be 25.6 millimeters. 25.6 millimeters. And you should be able to calculate the retention factor for each dot, separate out each mixture you examined, and repeat this step for each sample of Kool-Aid. We already did all 3 samples. And so, yeah, you should have enough for your lab report. So for the grape, the solvent traveled 5 centimeters. This is centimeters. 5 centimeters. Oops. So the solvent traveled 5 centimeters and the dot traveled 4 millimeters. For the orange, okay, hopefully you guys can understand this. So the solvent traveled 5 centimeters, and then the pink color traveled 4 millimeters, and the yellow color traveled 11.2 millimeters. Okay, and lastly, the black cherry. Okay, so for the black cherry, we got the solvent traveled 4.3 centimeters. 4.3 centimeters, and then the pink color traveled 10.9 millimeters, and the blue color traveled 25.6 millimeters. And note these numbers are from the dot. So dot up. And you guys could just cross out the cherry column in your results. Okay, so we're ready to do the column chromatography. So label 5 100 150 ml beakers. I've already got that done. I'm gonna start putting 15 mils of Kool-Aid into the 100 milliliter beaker labeled Kool-Aid. So I'm gonna use a graduated cylinder. Now put 15 mils of 70% isopropyl alcohol into the appropriate labeled beaker. I'm going to rinse this out. So that's 70%. Into my 70%. And I'm going to go ahead with the 25%. And then my 5%. Then 15 mils of DI water. 10 mils of the 70% isopropanol water into the syringe. So here's my syringe. So I'm going to take, this is in cc's, but note cc's, milliliters, same thing. So now I'm going to go ahead and add 10 mils of 70% isopropanol. And then I'm going to attach the column to the syringe. And then I'm going to push the isopropanol through the column into the waste container. Then I'm going to add 10 mils of DI water to the syringe. And then push that through the column. Then I'm going to go ahead and add 10 mils of Kool-Aid to the syringe. And then push that through the column. Gently push the colored solution in the column. Your column is now loaded with sample mixture that you are trying to separate. Take 10 mils of the, so gently push the colored solution into the column. Your column is now loaded with sample mixture that you are trying to separate. Okay, so push this through. Take 10 mils of isopropanol, 5%. So 5% right here. And attach it to the column. Gently push the solution through the column. You will see a colored solution beginning to move through the column. As that approaches the end, the column, catch the solution leaving the column in a test tube. Okay, so I'm going to push this through. And catch this through the test tube. Now let me just read this again. Okay, so we're going to catch it. Push additional 5% solution to the column until the first colored solution has been collected in the test tube. So we're going to add a little more because it was still coming out to be that color. Maybe a little bit more. Some more isopropanol. Okay. Okay. That's pretty much all that pink-orange color. When the first color solution has been collected, remove the syringe from the column and take 10 mils of 25% isopropanol. So I'm going to put this back in there. Whoops. Wrong one. Okay. 25%. So we're going to take 10 mils. Add it to the tip of our column. Push the 25% solution through the column until another color solution begins to come off the column. Okay, now I'm going to go get another test tube. Okay, I'm going to add a little bit more blue, 25%, just because there might still be a little bit left in the columns. So I'm going to make sure to get all the color out. All right. If needed, push additional 25% solution through the column, as we just did. Once all the color solutions have been collected, push 10 mils of 70% isopropyl alcohol. So we're back to the 70%. And I don't have enough, so we're going to have to grab a little more. Okay. So we're going to do this into the waist, I'm imagining. Once all the colored solution has been collected, the column you should white again, push 10 mils of 70% isopropyl alcohol, then 10 mils of DI water, okay. Now the DI water, also have to add some more. Pushing this through the column. We should now have the dye separate and continue with an additional chemical analysis on each from here. So, we only have grape. So now you should be able to figure out all the calculations from there. So out of, just to give you guys a little closer view here, out of this, which is like a really dark purple, almost black color, we got these two colors.